Hello friends, I am Gauri Boite, Assistant Professor in VP IIT Baramati. I welcome you all in my video lecture on subject Engineering Mathematics 2. Today my topic of lecture is beta function and this is my third video on beta function. So here I solve some more examples on beta function. Now evaluation of some integrations using beta function we see. For that, I recall some definition and properties. So, first definition of beta function is integration from 0 to 1 x raised to m minus 1 into 1 minus x raised to n minus 1 dx, where these m and n are positive real numbers and this is the function of two numbers m and n. It is called as beta mn. So, it is denoted as beta of m comma n. So therefore, when I replace this m and m by m plus 1, n plus 1, so beta of m plus 1 comma n plus 1 is nothing but the integration from 0 to 1 x raised to m into 1 minus x raised to power n dx. So now we use this as a formula. I repeat one more times, integration 0 to 1 x raised to m 1 minus x raised to n dx. It is beta of m plus 1 comma n plus 1. Then beta mn is same as gamma m gamma n upon gamma m plus n. This relation between beta and gamma. Beta mn is gamma m gamma n upon gamma m plus n. Then third property, the value of integration 0 to pi by 2 sin raised to p theta into cos raised to q theta d theta is 1 by 2 times beta of p plus 1 by 2 comma q plus 1 by 2. Okay. And one more property, the value of integration limit from 0 to infinity x raised to power m minus 1 upon 1 plus x raised to power n plus n dx is beta of this m comma n, beta of m comma n. Now for basic definition properties, you can see my video lecture 1 and 2 on this beta function. Okay. Now here in this lecture, I solve more examples on these last two properties. Now first example we see. Evaluate integration from 0 to infinity x raised to power 9 into 1 minus x raised to power 5 divided by 1 plus x raised to whole raised to power 25 dx. Okay. So let given integration I is integration of x raised to 9 into 1 minus x raised to 5 divided by 1 plus x raised to 25 dx. Okay. So here I first multiply this x raised to 9 inside. It become integration 0 to infinity x raised to 9 minus x raised to 9 into x raised to 5, that is x raised to 14 upon 1 plus x raised to 25 dx. Now I separate the denominator as well as I separate the integration over these two terms. So this I can write integration 0 to infinity x raised to 9 upon 1 plus x raised to 25 dx minus integration 0 to infinity x raised to 14 upon 1 plus x raised to 25 dx. Now I rearrange this 9 as 10 minus 1 because I want m minus 1 of the type of term, and here this 14 as 15 minus 1. So you add here plus 1 minus 1, it becomes 15 minus 1. Here 9 become 10 minus 1. Since integration, we know the formula 0 to infinity x to the power m minus 1 upon 1 plus x raised to power m plus n dx is beta of mn. So to apply this formula, I split this 25 according to my m. So at 25 here write 10 plus remaining number is 15. Here my m is 15, so I write this 25 is 15 plus 10. So this is an important step, writing denominator power, observing the m, and then split the whole power as m plus n. Okay. So by this property, value of first integration is beta of 10 comma 15 minus here beta of m comma n. So m is 15, n is 10. So it is beta of 15 comma 10. But we know beta mn is same as beta nm. So it becomes beta 10 15 minus beta 10 15. Value of this is 0. So similar problem you can solve. Integration 0 to infinity x raised to 8 into 1 minus x raised to 6 upon 1 plus x raised to 24 dx. So if you simplify this, you get it is x raised to 9 comma 15 minus beta of 15 comma 9, and you get answer is 0 for this problem. Okay. Now we see next example on beta function. Evaluate integration 0 to 1 x square plus x cube upon 1 plus x raised to 7 dx. Okay. Now here if we observe, the integrand contains x square plus x cube and denominator is 1 plus x raised to 7 power. So we split this numerator x square denominator for this x square and x cube, and also we split integration and we write it I1 plus I2. Now if we have to apply the formula, limit we required 0 to infinity. So here in the second integral I2, we write integration 0 to 1 x cube upon 1 plus x raised to 7 dx. First integration as it is. In I2 we use substitution. In I2 we use substitution. X is equal to 1 by t, dx become minus 1 upon t square dt. And the limit, if we check, limit of x changes from 0 to 1. So when x is 0, t become 1 upon x, 1 by 0 is infinity. When x is 1, it become 1. Now we continue this example. I2 limit now changes from infinity to 1. X we replace by 1 by t. So x cube become 1 by t cube. 1 plus x become 1 plus 1 by t raised to 7. And important thing, don't forget to replace dx. Dx become minus 1 upon t square dt. Now I take this minus sign outside. Integration infinity to 1. 1 upon t cube into this 1 upon t square, and I cross multiply this. T plus 1 raised upon t raised to 7. So it becomes t raised to 7 upon 1 plus t whole bracket raised to 7. So if we simplify these powers, this t raised to 5, t raised to 7 upon t raised to 5 become t square upon 1 plus t raised to 7. And also we change the sign with minus. It become integration 1 to infinity t square upon 1 plus x raised to 7 dt. Now this is definite integral. So variable is independent. So I now again replace t by x. No problem. Integration remains same. So I replace this by integration 1 to infinity x square upon 1 plus x whole bracket square dx. Now I write I is equal to I1 plus I2. So my I1 is integration 0 to 1 here. In fact, example I is I1 plus I2. So this I2 now replace by integration 1 to infinity x square upon 1 plus x bracket raised to 7 dx. Now if we observe this, integrand becomes same. Only limits here from 0 to 1. Here it is 1 to infinity. We know that integration a to b f of x dx plus b to c f of x dx we can write directly a to c. So here we write this integration 0 to infinity x square upon 1 plus x whole raised to 7 dx And now I write this 2 as m minus 1, that is 3 minus 1. And now I get m is 3. So denominator 7 I write 3 plus 4. So my m become 3, n become 4. And now I use this property. So according to this, value of this integration is beta of m comma n. So it is beta of 3 comma 4. Now we know relation between beta and gamma. So beta 3 4 is gamma 3 into gamma 4 upon gamma 7. So again gamma 3 is 2 factorial, gamma 4 is 3 factorial, gamma n is n factorial, and gamma 7 is 6 factorial. So after simplifying this, you will get answer 1 upon 30. So value of this integration is 1 by 30. Okay. Now next examples we see on the trigonometric properties. So first example, evaluate the integration 0 to pi by 2 root of tan theta d theta into root of cot theta d theta, limit of both integration from 0 to pi by 2. Now let I is given integration 0 to pi by 2 root tan theta into d theta into, this is not inside integration, this is another one integration, this is one integration, into integration 0 to pi by 2 root of cot theta d theta. So we write this I is product of two integrations, I1 and this is my I2 integration. So this I1 is integration 0 to pi by 2 root tan theta d theta, and I2 is integration 0 to pi by 2 root cot theta d theta. Now first I solve this I1. So I1 I write integration 0 to pi by 2. Root of tan theta I write in sin and cos. So it is sin 1 by 2 theta upon cos 1 by 2 theta d theta. Again I take this cos to numerator. It become my integration 0 to pi by 2 sin raised to 1 by 2 theta into cos raised to minus 1 by 2 theta d theta. Now this is of the type sin raised to p theta into cos raised to q theta d theta, and integration limit from 0 to pi by 2. So value of this integration is 1 by 2 times beta of p plus 1 by 2 comma q plus 1 by 2. So here comparing this, value of p become 1 by 2, q become minus 1 by 2. So this value is 1 by 2 times beta of 1 by 2 plus 1 upon 2 comma q is minus 1 by 2. So minus 1 by 2 plus 1 upon. So if I simplify this, I get 3 by 2 by 2, that is 3 by 4. Here 1 by 2 upon 2 means 1 by 4. Now we know beta mn is gamma m into gamma n upon gamma m plus n. So beta 3 by 2 comma 1 by 3 by 4 comma 1 by 4 is gamma 3 by 4 into gamma 1 by 4 upon gamma 3 by 4 plus 1 by 4. So denominator is 1. So 3 by 4 we can write 1 minus 1 by 4. And now it is of the type gamma p into gamma 1 minus p. And we know the formula gamma p into gamma 1 minus p is pi upon sine p pi. So pi is 1 by 4. Now we substitute sine 1 by pi by 4 value is 1 upon root 2. And it become 1 upon root 2, that is root 2 upon 2. It is 2. And here it become answer pi upon root. Okay. So here we find out I1 is pi upon root 2. I give this is equation A. Now we continue this example for finding I2 value. So I2 is again integration of root of cot theta d theta, limit from 0 to pi by 2. Again I write cot theta is cos of theta upon sin theta, and root of cot theta nothing but cos raised to 1 by 2 theta upon sin raised to 1 by 2. Now I rearrange it, it become integration 0 to pi by 2 sine raised to minus half theta into cos raised to half theta d. Again we use that property, sine raised to p theta cos raised to q theta d theta is 1 by 2 times beta of p plus 1 by 2 comma q plus 1 by 2. Here p become minus half and q is 1 by 2. So this value is 1 by 2 times beta of 1 by 4 comma 3 by 4, and we already proved in this value of this is pi upon root 2 in previous slide. Okay, so just you refer previous slide for this value, and now my I become I1 into I2. Value of I1 is pi upon root 2. Value of I2 is pi upon root 2 from equation A and B. So I become pi square upon. So therefore the value of given integration we prove that root of tan theta d theta limit from 0 to pi by 2 into integration of root cot theta d theta limit from 0 to pi by 2 is pi square upon. Now as a previous one we simplify one more example. Root of integration 0 to pi by 2 root of sine theta d theta into integration 0 to pi by 2 1 upon root of sine theta d theta. We have to evaluate value of this integrations. Now we let I1 is given integration, and the first part of integration we consider I1 and the second part is we consider I2. So I1 we consider integration 0 to pi by 2 root of sine theta into d theta, and I2 is integration 0 to pi by 2 1 upon root of sine theta d theta. Now first we solve this I1. So I1 we rearrange integration of 0 to pi by 2 root sine theta, we write integration 0 to pi by 2 sine raised to 1 by 2 theta into, there is no term of cos but we write cos raised to 0 theta, it is 1, and we use the property integration 0 to pi by 2 sine raised to p theta cos raised to q theta d theta is 1 by 2 times beta of p plus 1 by 2 comma q plus 1 by 2. Now here my p is half, q is 0. So it is 1 by 2 plus 1 upon 2 comma 0 plus 1 by 2. So when I simplify this part I get it is 1 by 2 times beta of 3 by 4 comma 1 by 2. And we know beta mn is gamma m into gamma n upon gamma m plus n. So beta 3 by 4 comma 1 by 2 is gamma 3 by 4 gamma 1 by 2 upon gamma 3 by 2 plus 1 by 2. It is 1 by 4 plus 3 by 4, that is gamma 5 by 4. This is the value of integration root of sine theta d theta from limit 0 to pi by 2. So I keep this is in equation A. We are using next this equation A. Now we solve I2. I2 is integration 0 to pi by 2 1 upon root of sine theta d theta. So I rewrite this 1 upon root sine theta is sine raised to minus half theta. No term of cos, so I write cos theta raised to 0 d theta. Now again it is of the type integration 0 to pi by 2 sine raised to p theta cos raised to q theta d theta. And we know value of this integration is 1 by 2 times beta of p plus 1 by 2 comma q plus 1. So here my p become minus 1 by 2, q is 0. So value of integration is 1 by 2 times beta of minus 1 by 2 plus 1, that is 1 by 2 upon 2, 1 by 4, 0 plus 1 by 2, that is 1 by 2. When I simplify this, it becomes beta mn is gamma n upon gamma m plus n. So beta 1 by 4 comma 1 by 2 is gamma 1 by 2 into gamma 1 by 4, gamma 1 by 4 into gamma 1 by 2 upon gamma 1 by 4 plus 1 by 2, that is 3 upon. Now this is my value of root of 1 upon root sin theta d theta, integration from 0 to pi by 2. This I consider equation B. Now I integration is I1 into I2. So I become value of A from my previous calculation. It is 1 by 2 root 3 by 4 into root 1 by 2 upon gamma phi 1. So I substitute this value of I1 from equation 1 and I2 from equation B, I1 from equation A. So if we simplify this, 1 by 2 become 1 by 4. 3 by gamma 3 by 4 upon this gamma 3 by 4. This term will get cancelled. So what is remaining? 1 by 4 times this gamma 1 by 2, gamma 1 by 4 into gamma 1 by 2 upon gamma phi 1. Now again I write this gamma phi by 4 is 1 by 4 gamma of 1 by 4 plus 1. Now we know gamma n plus 1 is n gamma n. So I write gamma 1 by 4 plus 1 is 1 by 4 times gamma 1 by 4. Now this 1 by 4 will get cancelled with this 1 by 4. Now gamma 1 by 4 will get cancelled. So what is remaining? Gamma half into gamma half. And here gamma half is root pi. We know property of gamma function. So gamma half into gamma half is root pi into root pi, which is nothing but pi. So here I stop. So thank you very much for watching this video, and to watch more videos, subscribe my channel Gauri Bhote. You can watch and enjoy more videos on this engineering mathematics 2 subject. Thank you.